drill bit and introduction to directional drilling. Guy Kemen, you can go ahead.
All right, thanks, Mohammed. So today is the last day of our online course. So like Mohammed said, we'll be talking about bits in the basics of the directional drilling. I tried to save some time in here, and then you guys have more opportunity to ask questions. So let's get started with the bits. The bit types, as you see in here, the bit types, we have two main types of bits. One is in here you see, or this one, it doesn't matter. It has 3 cones with the cutters or teeth. And then the other type is a fixed cutter bit. That means you don't have any cone like this one. These, while drilling or while pumping, they are rotating all these 3 cones, but the PDC bit doesn't rotate. That's the main difference between them. And they are generally consist of these 2 types. So drill bits, we have roller cone bits like these, as we said in the fixed cutter bits like this one. For the fixed cutter bits, we have diamond bits and PDC bits. Diamond bits doesn't have any application in Kurdistan in most of the oil wells. But in some geothermal wells out here, they use the diamond bits. But the PDC bits are very common in drilling wells. And then on the other hand, you have the roller cone bits, and roller cone bits can be classified into mill tooth bits and inset bits. And then those 2 types can be also classified to general bearing and then roller bearing bits. So if we talk about PDC bits, the PDC stands for polycrystalline diamond compact. Okay, use artificially made diamonds. It has some diamond in its composition, but it's artificially made diamonds. Okay, and most of the time we use the PDC bits. Nowadays, it's proven that it's more aggressive and more durable, and it gives you more ROP PDC bits compared to the triacone bits or the roller cone bits. But on the other hand, it creates a lot of torque and drag while drilling. It's more aggressive. The fixed cutter bits, and that's a PDC bit. This type of bits called PDC bits, as you see on the share screen. The elements of the PDC bit, and here it's very important for any drilling professional to memorize all the parts of the PDC bits, because you will need this for a lot of analysis and drilling bit grading and many more analysis while drilling any well, especially for the drilling engineers. They need to be very familiar with the parts of the PDC bits. If you take a look at here, in the very center, deep down, we have the cone, and then we have in here nose, and then you have shoulder, and then you have tungsten carbide matrix. This is the tungsten carbide, and then you have the gauge, and so on, all these parts. Why it's important to know all these parts? Because when we use any drill bit, any PDC drill bit, it's important to know these parts so you can analyze where is the biggest wear or damage on the bit later on, so you can improve your bit design for the future wells. So you focus on any weak point on the bit. For example, every time you use 8.5 bit and you see on the nose and the cone, you see the biggest damage, the biggest part of the damage is on the cone and the nose. So you as a drilling engineer need to look after this for the future wells, so you can improve this, and you can dig out the data, collect the data, why these 2 parts, for example, are having the biggest share of the damage. So you can improve and improve and improve, so you can minimize the number of runs of the bits. The body material of the PDC bits, you have 2 types. You have steel body in one piece, and the functions or the uses or the advantages of this is high precision and then simple repair and no weld. Just like you see, this one is one piece. And then also we have tungsten carbide matrix on steel shell. Like you see, these are all tungsten carbide on the shell, and the advantage of this is the erosion resistant. The cutters of the PDC bits have standard sizes. It doesn't start like 8, 9, 10, 11 like this. It has 19 millimeters, 16 millimeters, 13 millimeters, 11, and 8. This 8 millimeter, for example, means the diameter of the cutter, okay, or of this insert. And when we call any bit, we start, for example, I say this bit is 8.5 bit, but it's 713, for example. 713 means you have 7 blades like this. For example, this is 1, 2, 3, 4, 5, 6, 7, 8. This is this bit has 8 blades, 1, 2, 3, 4, 5, 6, 7, 8, and then you need to know the size of the body of the diameter of the cutter. So you can call the bit 7, or in here 8. If it is 13 millimeter, just like this one, then you call it 713 or 713. That's how you call the bits. The roller cone bits, and here you have some alternative names. They are also called rock bits, Tricon bits. These bits nowadays are mainly used for clean out runs. That means just for hole conditioning, not mainly for the drilling. And it's cheaper than the PDC bits, and it creates also less torque and drag while drilling. Basic types of the roller cone bits, as you see in this picture, it can be easily recognized. This is what we call tooth bits. It has big teeth like this, and then you have insert bits like this. This can be carbide inserts. And also in here you have steel tooth bits, and also you have mill tooth bits. These teeth can be designed in steel material, or it can be designed as a mill. The mill is usually used for drilling or milling the material, for example, or sometimes if you set your casing and then you drill out your shoe track just to be ready for the next section, you use a bit like this or a mill tooth bit. Then because you mainly mill out the shoe track, which is metal or aluminum or whatsoever, so you can be ready for the next section without using the PDC bit for drilling the metals. So you can use this one. Or sometimes if you have a junk for any accident, someone drops down a junk into the hole, any piece of a metal, it can be hammer or something like this, and you cannot fish it out, then you pick up a bit like this, a mill tooth bit, and you're going to go down and start milling. That's the difference between milling and drilling. Milling is mainly used for a very slow drilling process of metal. That's what we call milling. Roller cone bits components. Again, these are important to know, especially as a drilling engineer. If you have any opportunity in the future to work as a drilling engineer, you have to know all these components for analysis, for studies, so you can improve your bit selection. You have 3 cones, obviously, cone number 1, cone number 2, and cone number 3. These rows or cutters must be in 2 parts because we will need it later on for the IADC Dell grading analysis. This part, as you see my mouse cursor, these are called inner row, inner teeth. And then these are called outer. Okay, as if you pull out the bit and then you're gonna analyze what has happened to your bit, and you check if the biggest share of the damage has occurred to your outer cutters or the inner. If it is outer, that means these cutters are responsible to touch the wall of the well, but the inners are mainly responsible for making the hole. and the outers are mainly doing like reaming, we can call it. And here we have nozzles. Of course, these nozzles are replaceable. We can replace the nozzles anytime according to our hydraulic calculations. That's another drilling engineer's job, to calculate what the nozzle size is required to be used in any BHA. We have here the pin connection, which is usually the regular connection for the top sections, and then in the 8.5, it's 4.5 connection. And also in here, you have the bit body. All this part is, once you have any opportunity to work in any oil company or even in the university, you can be familiar with all these parts. These are the nozzles. There are two types of nozzles. This is only for the triacron bits. Shrouded type, which has this kind of spring ring. You can use it for the nozzle, and standard type of the nozzle. Now, if we talk about the failure mechanism, failure means how we cut, how we drill a well. There are mainly two types of the rock failure mechanisms. One is shear failure. That's done usually by the PDC bit. It's, as you see in this picture, it grinds the rock. It doesn't crush it. It just grinds it. Because if you take a look at the PDC bit in here, you can imagine how it works. And here with these cutters. But with this roller bits, and here you can see it touched to the bottom of the hole and it crushes the rock. Like this one, it's called compressive failure. So just very briefly, the PDC bit does the grinding mechanism, as you see in this picture, and the triacron bit does the crushing the rock. And then also you can see the cuttings. If you put it under the microscope, you can see the shape of the cuttings, which one is drilled by the PDC or the triacron bits. This is just some calculation for if you use the compressive strength or the shear strength. So nothing so important about this. Drilling mechanism, again, as we discussed, the shear, this diamond bit is also shearing or grinding the rock. Now, we need to know the IADC classification for both roller comb bits and also the PDC bits. Always a part of the name of the bit, like I said, any bit you say this bit is 8.5 713, I said that means 7 blades and 13 millimeter of the cutter size. But in here you have also the IADC classification for any bit. How do I know this bit is good for medium hard formation, soft formation, or hard formation? You can know from these digital numbers in the letter for the roller comb bits. The first digit is for the formation hardness. The lower the number is used for the softer formation, as you see. 8 is extremely hard and abrasive formations, but 1 is for soft formation with low compressive. The second digit is the cutting structure type for the bit. Okay, 1 refers to the softest, and 4 is for the hardest formations. You have the third digit, which is for bearing or gauge description. It tells you whether that roller, this cone is a standard roller bearing, or it has a roller bearing, air, cool, and so on. So these are the classifications for the roller comb bits. The last thing is a letter. The letter indicates the feature available. For example, in this example, G indicates the gauge body protection, or it can be extended nozzle, things like that, center jet. So, of course, you as a drilling engineer, and most of the time as a drilling supervisor, also any drilling professional, you have all these manuals in front of you. If you forget about anything like this, And usually what we do, we post all these informations on the wall in our offices, so you can go back anytime to get information about the bit classification. The IADC classification for, let me put this one down here. For the IADC, it's a little bit different. For example, the first one is not a digital number, it's a letter. The letter means either, if it's M, that means you have a matrix, okay? It can be tungsten carbide. If it's S, that means it's still the composition of your bit. The second digit is the Keter density. 1 to 4 diamond bits, 6 to 8. That means the lower the number, the higher set the bit. And then you have the third digit, the Keter size and type. Okay, so 1 indicates any Keter bigger than 24 millimeters. If it's 2, that means it's between 14 and 24. In our example, it's 3. 3 is between 8 and 14. So on until 4. 4 is if you see in here, for diamond bits, 1 represents for a natural diamond, 2 is TCP. So the same sequence for 1, 2, and 3, and 4. You have also the last digit, which is the profile. The final digit indicates the general body style and varies from 1, flat profile, this profile of the bit, to 4, long flanked turbine style. So this is the profile of the bit, the last digit. This is the IADC classification for the bit. Another classification we have is, which is very, very important, especially if you work as drilling engineer, it's your responsibility to collect all this delt grading for the bits. Delt grading means you run any bit and then you pull out. You need to know how your bit performed, whether it performed well, it was in the desired way the bit was performing, or it didn't drill well, it didn't last enough in the well, the ROP was not a good ROP. So anything like that, you need to grade. Just like you test the bit, you need to grade it, how satisfied you are about your bit. So the delt grading table is pretty simple. You have 8 columns. The first and second columns are about how much is worn or chipped or cut from the cutters. So from that, you know that your bit did a great job or no. The first column is for the inner cutters. For PVC, the inner cutters, if you take a look at here, this is a full circle, right? Your bit. For example, if the bit is 12 1/4, so you just divide by 3 pieces. 2/3 of the diameter of this bit size, 2/3 is called the inner. Anything out of 2/3 of the bit is called the outer cutters. So for the first column in here, you are checking the 2/3 of your circle, of your bit size. And then if you see this, you just imaginary, you divide this cutter, this small cutter, into 8 pieces or 8 scales. For example, if you see about half of it is cut, is lost, or anything like that, you call this 4 divided by 8, you call it 0.5, just like this. So in here, you call the same, okay? But this is only for 1 cutter. But you need to take the average of the cutters, the inner cutters, which are in the area that we discussed, 2/3 of the bit. You take the average of all the cutters, and then you say whether all the cutters, the average of all the cutters, the inner cutters it's 2/8 cut, or it's half, which is 4 in this case, so on. You do the same thing for the outer cutter. The outer cutter, like we said, is anything between out of 2/3. You take 2/3 of the bit, and then anything beyond that, these are outer cutters. You do the same thing. You have how many cutters, you take an average of that, and you see how much of the cutter is worn or lost or cut. For example, if you can see, if you divide this into 8 scales, any outer cutter, and you see most of them are about a quarter worn or cut, then a quarter means 2/8. In this table, you just call 2. So for example, the dull grading we are doing is 4, 2, and then you need to know what's happened to your cutter, all these cutters. Of course, you can visually check if the cutter is broken or if it's chipped, or if you see the bond is failed, or you've lost, sometimes you've lost the cutter, or sometimes you can see the impact or the traces of heat on your bit and so on. There are many characteristics you can call by just looking at the bit. And then you also need, in the 4th column, you need to know where the damage has happened. That's why I said it's important for you to know the nose, the cone, the gauge, the shoulder, the taper, all the areas of the bit, so you know how to dull grade the bit. And in here you can see in the 4th column, you can call it if, for example, the example we talked about, if we see this inner very center cutters are worn or cut, that means it's your nose. The nose area you just call N. So far our bit grading is 4, 2, broken teeth or broken cutter, BT, so 4, 2, BT, N. That's how we call it. And then bearing, if for PDC bits, you don't have bearing. Bearing just, it's only exists in the roller cone bits. It's a bearing, right? It's rotatable piece of the bit. But for PDC bit, you don't have it, so you always take it X. And here you call it X because you don't have any bearing. And then the size of the bit, this bit can be in the hole for days, sometimes for weeks. When it comes out, it was supposed to be 8, when you run in hole from the manufacturer, it's just for example, 12¼ bit, okay? When you pull out, it has drilled 1,000 meters. So there is a possibility there is some worn on the diameter, on the gauge area, and the taper area of the bit. So the bit can be under gauge. That means it can be, instead of 12¼ 12/1/4, it can be 12/1/8 or 12/1/16. So you have a ring, just like a normal ring, like this. You put it on from top side, you put it on the bit, and then you can see if it's engaged or there is a gap when you put the ring around like this around the bit. So you can know if your bit is still engaged or under gauge, and then you can put any 1/16 inch has been reduced from its diameter, or probably 2/16 has been reduced, and so on. The 7th column is any bit can have 2 characteristics, 2 problems, or 2 types of damage on the bit. The bit can have the broken teeth, and it can also have chipped teeth, right? You can lose your nozzle, for example, and at the same time your cutter. So you need to have 2 columns for the characteristics, the type of the damage on the bit. So you just, on the 7th column, you just put another name. If you see the bit has only one type of damage, one characteristics, for example, all you can see on the bit is just chipped. And here you just put rerunnable. That means it doesn't have any second of characteristics. And also the last column is why we pulled out the bit. BHA, that means to change the BHA. Downhole motor failure. The motor had a failure, but the bit was okay. logging runs, and so on. If you read this, you can understand the reasons why we pulled out. So this Belgrade classification is quite important for the drilling engineers and everybody else to improve his bit selection and bit design. So that was all about the bit. If anybody has any question, I'm ready to answer. I think we've got about 8 minutes or 10 minutes, something like this.
Yeah. Kemal, thank you very much for this informative seminar. The gents, if you have any question, you can ask Kemal. Maher Sahmi added another information. He said there is another location code in column 4, A or rows.
Location of the characteristics?
Maher, can you unmute yourself? Just 1 minute.
How are you, Kemal?
I'm good, Maher. How are you doing?
Hello?
Hello, I can hear you, yes.
One comment in location characteristics for primary door characteristics. It's called A when we have a weir or chip tooth or anything on all rows or all areas.
That's right. That's right. That's right.
Yeah.
Yeah, that's right. Yeah, like Agmar said, if you have damage on the bit in all areas, the entire bit body, then you call it A. That means all area. That's right.
Kemal, asking, can you talk about the price of bits?
Depends. We usually use the PDC bits. It depends on the market. It depends on the customer, but it can be vary between $20,000 to $40,000. And it could be more or less also, but this is the average price I can say.
Can I actually have a question? When do we use carbide micro drilling bits? The tungsten carbide micro drilling bits?
Well, we have never used those kind of bits in Kurdistan. I don't know for some other applications, some different types of wells, gas wells, geothermal wells, it can be used. But in Kurdistan,
so we didn't use in Kurdistan?
No, PDC bits is the main one we are using. Rarely we use the normal Triacon bits in Kurdistan. I'm talking about because the wells are all similar and they are not that deep wells.
Yeah, thank you, Kemal. Any other question you can ask? Ibrahim Yunus, go ahead.
Yeah, we have about 8 minutes now. I can see that's good.
8 minutes.
Good time.
Any question?
Yeah. Yeah, they can ask about previous topics. It doesn't matter. We can answer the drilling fluids, the cementing, casing.
So, any question you can ask?
If nobody has any question, I can just in the last 5 or 7 minutes, I can talk about how we improved drilling bits in HKN. It's a good time to discuss about.
Okay.
And it's a significant.
Just so this question, and then type of bit is better. I think it depends on the formation, isn't it?
Yeah. Did they ask what's the best bit?
Yeah.
That was the question?
Which type of bit is better one? Yeah, it was the question.
Okay. That's a very, very general question. You cannot say this bit is the best. For our applications so far, PDC has proven it's the best. How we know it's the best if we don't drill several wells? For us, PDC has proven the best bit for us, and now HKN has its own design for the bit. Our drilling engineers with the bit providers, Smith or NOV or whoever, we design our bits as per our formations and our requirements. So, but the PDC we are using is more durable. Nowadays, like I mentioned yesterday or the day before, it can last for the entire section. So for each section, we use only 1 bit. But sometimes in the 6-inch hole, we use 2 bits because it's about 1,000 meter long section, the 6-inch hole. But for the previous sections, nowadays we use only 1 bit. In the bit, when it comes out to surface, it's still rerunnable. So we've done a big improvement in the bit design.
Kak Ahmed Rashid says he has a question. Yeah, Kak Ahmed, go ahead.
Kak Ahmed, yesterday, I guess his name was Abdussalam, he was asking about LWD, that how much we trust the data of LWD, and they are reliable or not?
Okay. The LWD, like I answered yesterday, we use it only for the interested section. In our case, it's the last section of our well, which is 6-inch hole. We use LWD. The data are pretty much reliable. There's no problem in terms of reliability of the data. And we can gather a bunch of information like resistivity, sonic. We've used also neutron density, gamma ray, deep angle, image, all this information we can gather them. We can gather them on real time. That means while we are drilling, we have all those data. We have all those data while drilling because we have real-time data. And also we have another set of the data, which is in the memory mode. So we have a battery in the memory and the memory in the tools, the LWD tools. So once we pull out the tool to surface, we can download the data, and then with the real time, we correlate them. They are very much reliable data, and it gives you a big favor in terms of delivering your well.
Thank you so much, Kak Ahmed, and hello again, and Kak Ahmed Rashid for your great concern for my last question. Let me to discuss about it. I mean, it's about the reservoir formation. As you know, it's important and so crucial to control it. As I said in the yesterday, we use well logging, yes, to predict some situation gonna happen to us in the reservoir.
Right.
Okay, we have one well, we are drilling in this experience and in this situation. But as we know in the field, so many options, so many formation are the same and they have the similar situation, similar condition, you know, like pressure, like porosity, permeability, okay? I said, how much you trust this reliable information for the next step or next well? Because as an engineer, we should predict some thing gonna happen. Yes.
Yes. Okay. If I talk about HKN, okay, just for example, I'm pretty sure worldwide is the same.
Yes.
In the past, when we were drilling the exploration wells or the first wells in many areas, second wells, we needed more data. So we used to run a wireline because our wells were vertical or near vertical wells. But nowadays, we are in the development phase, right? And as we will discuss later on about directional, and our wells in the 6-inch hole, when we get to the 6-inch hole, our reservoir our well in the reservoir is above 45 degrees inclination. So it's almost going towards horizontal. So there's no way to run wireline. Wireline is, as you know, it's on cable, so we cannot run wireline logging in our 6-inch holes nowadays because they are high deviated wells. So what we do, we run LWD tools, some of them with the drilling BHA. While drilling, we have some LWD tools within the MWD tools. For example, we have microscope tool, we have sonic scope, and then above them we have MWD tools. So we can gather all the information without using any wireline logging. And this data is 100% reliable if you are in the development phase. For example, yeah, I know we have 1 minute and a half. In the past, okay, just give me a few seconds. Nowadays, we are in the development phase and we've drilled many wells next to each other. So we removed a lot of logging program in our plan because we can rely on the previous wells logging data. So it's reliable and we can trust those logging.
Great, thank you so much. I want to get this as a practical man. You are here to tell us about it. Thank you so much.
No, any time, and I've talked to Kag Mohammed and Ahmed. If there is any opportunity, I can do any presentation in the university as well.
Thank you very much. Can ask in gas drilling fluid how bits are called, because I think we use gas instead of mud.
Okay, in this is one of the disadvantages of the gas wells. In our wells, the wells are not high temperature wells, especially in the Duhok province. So we don't have much problem with the heat while drilling. So even gas can work without cooling down.
Okay, so I'm just going to end up the meeting because less than 1 minute left, maybe 10 seconds. Thank you, Kemen. We will be back in about 10 minutes.
Yes, sure.
Okay, thank you.